All right, so now we've learned extinction rates are elevated. We've learned that we are causing those elevated extinction rates. How on earth do we reverse this? I think we all need a little bit of good news. And the thing is that conservation efforts can actually reverse declines in biodiversity or at least slow them. But there are definitely some great examples of where we have provided the opportunity for an organism to make a major recovery from the brink of extinction. So let's go talk about how conservation efforts work. So one of the ways in which we've realized we can support populations to maintain themselves in perpetuity is just to have a population size that is large enough so that if something random happens to that population, it won't disappear entirely because some individuals will survive ultimately, just randomly by chance. So you'll learn about this in evolution, if you haven't already, is the process of genetic drift. And genetic drift is this random loss of genotypes through time as a result of pure accident. So that pure accident is environmental variation in many cases. And so what researchers have discovered is the smallest population size one population could persist at, even when there is environmental variation. And we call that the minimum viable population size. So around the world, researchers are looking at all species in the world, as many as they can handle, and trying to identify what the minimum viable population size is for that population, or what it is for similar species, and then seeing whether each population is above or below that threshold. When the population is below that threshold, then the alarm bells sing, and we start to see that that conservation actions start going on. But when populations are above, well above that minimum viable population size, then we end up seeing that we are less concerned about them. So we call them lower concern. So that is one viable approach that many researchers use in order to understand whether a species needs to be conserved or not. So here's an example where there's this beautiful major ecosystem called the Greater Yellowstone ecosystem. And of course, it includes Yellowstone National Park, but is actually much larger than Yellowstone National Park. It also includes the Grand Teton National Park and has a whole pile of other really interesting physical features in that space. The ecosystem itself, you can see as a dotted line, is quite large in this space. In fact, there's a really interesting book that describes the migrations between the migration patterns that occur between this park and all the way up into Alberta as well, because within this park and many other places, or this ecosystem and many other places, there are these shared organisms that migrate long distances. So Yellowstone includes a bison herd, it includes major wolves, a wolf pack or several wolf packs, it includes elk. There's a whole pile of major mammals that depend on the persistence and connectivity of this ecosystem along with others. And so there's been this push to create connected ecosystems all the way up the Rocky Mountains. And so with this, when researchers are trying to decide how much space do they need to conserve in order to support this unique ecosystem, they look at minimum viable population sizes as well as migration patterns, reproductive patterns, a whole pile of key demographics to make sure that they could support, for instance, the key organisms that are so important within these ecosystems, like bison, like elk, like wolves, like bears. And they do this using that minimum viable population size model, among others. And so as we're starting to look around the world, one of the really good news information pieces is that now, more than ever,
there are protected terrestrial and marine areas. Through time, we can see that as time passes, we as humanity across the world put more and more land into protected areas than ever. It's a linear pattern so far. The percent land area protected increases proportionally with year. And while that's taken a long time to catch hold in marine ecosystems, we're now starting to see marine ecosystems also being conserved as well. Although this is taking a lot longer, and so it's delayed. It's delayed in part because some of the funny rules around who owns what, but also it's delayed because marine ecosystems are so economically important, not simply for harvesting of animals from that landscape, but also because we spend a lot of money transporting goods and services through water. And so because of that, it becomes complicated to work with politicians to conserve particular spaces. In many cases, humans have settled near biodiverse regions of the marine ecosystems because that feeds us, because that sustains those communities. And so it becomes a really complicated political problem. Now, not only have we been conserving more and more area, but we've also had really good success just actually making progress recovering organisms. So here in this image, I'm showing you 3 good news stories. The northern elephant seal has come back from the brink of extinction where we were harvesting it unsustainably for a very long time for blubber as European communities started expanding over here and trying to exploit it for oil. We have the California condor, which has recovered from DDT exposure for a very long period of time. Those populations are increasing in size every year these days. It's amazing. And then finally, the wolves and the elk of Yellowstone are increasing in population size again because we are now protecting both wolves and elk and not hunting either of, well, generally trying to minimize the hunt of both. That doesn't mean that we don't have work to do. We have lots of work to do. When we start to look around, here's an example of one country's data on how many organisms have been reviewed by the IUCN to figure out whether those species are of concern or are at risk of extinction. And you can see in this particular country, you can see that there are 333 least concerned conifers, which is great, but there are 177 threatened conifers in this particular location, 1,300 bird species that are at risk, 1,100 mammals that are at risk, and almost 2,000 amphibians that are at risk. This is a lot of work that we need to think in big ways, in imaginative ways, to figure out how to conserve not one species, but many species simultaneously. And this is the work that our generation is doing. One of my postdoc positions was simply to work with a Department of Defense, it was the US Department of Defense, to figure out a conservation strategy that would protect as many endangered species in the US as possible. And the reason why the Department of Defense was funding this was because the Department of Defense was the largest landowner that had land with species of concern on them, and so they couldn't do any activities on those pieces of land that would then threaten them, because in the US, at the time, the Endangered Species Act was federally regulated, so the Department of Defense couldn't violate any federal laws. They had to protect these threatened species. But there were so many of them, they needed help from conservation biologists to understand what to do in order to preserve them. So this is the work that we have to do. This is the good work. This is the solid ethical work. And I'm excited to see what's going to come out of the next few years.
Pretty stiff situations. So with that, I'm done my lectures for this week. I hope that you find some ways to rest and relax this week. And if you're listening to this on the Thursday when it's due, I hope that you find ways to relax and rest the following week. Okay? All right, take care. I look forward to conversations with you. Bye-bye.